All right, so let's start by looking at any questions you had on the review sheet. You finished the review sheet, you checked your answers. What questions did you have? Anybody miss anything? Anybody find an error? I know I have an error on the review sheet. Number 12, the answer should be an ordered pair, and I think I only put down the x coordinate. So I'll just do that one right now. So number 12.
You answered me like when the beer was over the top.
So for number 12, the answer I had, or the answer I should have had, was 0.787.933. That should be the answer to number 12. And I think anytime you're solving a system, your answer has to be ordered pairs. So you can't have just one number like I did. All right, other than that, anything on the review sheet that, yep,
Could we do 11?
11D.
Yeah.
So first thing we take care of, let me see, did I turn that on? Yeah, okay. Thank you. So the first thing we always take care of is the eyes. So this is going to be I root 3. This is going to be I root 6. This is just going to be 2I. So then I'm going to multiply, it looks like I've got 3 I's, I. And then I've got 2 root 18.
So you can multiply. I thought that you could only multiply the like inside if they were the same. Like of the radical. Like you can only do it if they were both 3.
No. You can only add them if they're both 3's.
Yeah, that's what I was.
But to multiply them, all they have to have is the same index. They have to both be square roots or cube roots or something like that. So I know that is 3 root 2. So it looks like I have I cubed and then 6 root 2. But I cubed I know is negative I. So I'm going to have negative 6I root 2 as my final answer. Okay. Anybody else from the review sheet? The second page, we did the whole first page. Second page, anything else? All right, how about that homework that I just turned back? Some of it was not very good, you guys. Anything from the homework that I just turned back? Quinn?
Can you do number 4?
This is P8, number 4. Says solve algebraically. That means not by graphing on your calculator. So we've got a little system of 2 equations. I always eliminate, that's just what I do. So I'm going to multiply this by 2. So negative 2x, 4y, negative 8. Uh-oh. Looks like everything cancels out on each side. So I'm left with 0 equals 0, which is true, right? It's not like 0 equals 7. That would be no solution, no intersection. this means that they have a lot of points in common. Remember, you are looking for where they intersect each other. So if you were to graph that line right there, I don't know what it looks like, but there it is. And then I graphed that one, they would be right on top of each other, wouldn't they? So what points do they have in common? They have all of these points in common, right? Now, do they have every point in the whole wide world in common? No. So those are all real numbers? No, that's just crazy. They have all of these points in common. Well, what are those points? Those are the ordered pairs such that, I don't know, 2x minus 4y equals 8. In other words, if an ordered pair is on this line, then it is part of the solution. Okay? All right, who else had a question? 5, solve algebraically. So again, that means no calculator. Alright, so we got a cornfield, it's rectangular, and it has a perimeter of 220 and an area of 3,000. Alright, so what did you do first, Parker? We gotta get started on this. What did you do?
I made two equations. I did 2x plus 2y.
Okay, so you called one dimension x and one dimension y. So 2x plus 2y was 220. And then
I did x times y equals 3,000.
x times y equals 3,000. That makes perfectly good sense to me. And then you have a little system of equations. So what did you do then?
I think I did like one substitution.
Yeah, I'm an eliminator, but I can't do that here, so I'm gonna do substitution too. So what did you do?
I just divided 3,000 by x.
Okay, so y equals 3,000 over x, and then did you leave that did you leave all those 2's in there, or did you divide them out? Okay, so you could divide them all out, but you didn't, that's fine. So 2x plus 2 times 3,000 over x equals 220. Alright, so 2x plus 6,000 over x equals 220. So we're going to clear out since I'm doing this algebraically, I'm going to clear out the x's. So 2x squared plus 6,000 equals 220x.
Yeah, I think that's right.
And then I can get it also equal to 0. So 2x squared minus 220x plus 6,000. And now, Parker, I am going to get rid of the 2's now. So x squared minus 110x plus 3,000. So once I get to this point, what are my choices? What do I have to do? Factor it, if I can see it. It does factor, but maybe, those are big numbers, maybe I don't see it. I could use the quadratic formula. Or actually, this one wouldn't be too bad. I could also include the square if that's what I wanted to do. But it does factor. So it looks like, I erased my picture, but it looks like my x could be 50 or 60. which means what about Y then? Y could also be 60 or 50, right? Yeah. Okay, and the unit on that is yards. And I wanted to find the dimensions, so 50 by 60. Because, remember, if X is 50, Y would be 60. Okay, anybody else? Alright. There are a couple more things I want to look at, and then I guess we'll just go ahead and start unit 1. Since nobody's got any questions. Alright, so let's just do a couple extra practice problems here. So I don't know, you got a piece of paper somewhere? You can write on the desk if you want, you just have to make sure you erase it completely. Markers and rags like that, thing back there in the back. Alright, let's see if you can solve that one graphically. You'll need your calculator for that. And solve that graphically. answer. I'm almost done with it.
Oh, but like, why?
All right, what'd you come up with? For this one right here, solve that graphically, what'd you come up with? Charlie?
X equals 0.441 and 2.104.
I'm good with those, but what? Is there another one? Negative
Oh.
2.838. So there's three answers,
Yeah.
right? Everybody okay with that? One thing, Charlie, and I love intersections, I like to use intersections, but something nice about getting everything on one side and using zeros is you don't have to worry about above and below, which is what happened here. You didn't look down far enough. So if you set it equal to 0, then all you have to worry about is where it crosses the x-axis. You don't have to worry about all that. All right, next. Okay, so that one's done. All right, now I want you to solve this guy right here with no calculator. So the one I just erased, the one you just finished, you did with your calculator. This one you're gonna solve without a calculator, all right? So go ahead and get started on that. See what you can do with that. how'd you do with the second one? I got this, how about you? I did it two ways here. I did it with a number line and my sign charting. And then, I'm not sure if you remember how to graph a cubic polynomial, but as soon as you get it backwards, you know it has these 3 zeros, and then remember a cube has this shape. Again, I don't know what you remember about that. But if you remember that, then clearly this section and this section is positive, and that's the same thing we got with the number line. Okay, good? All right, next. Work it backwards. Here are the roots to a quadratic equation. What is the equation? Can you work that backwards? You have the roots. We've solved it, gotten these answers. What was the original equation? All right, you ready to come up with an equation? X or something. What kind of equation you come up with? Annie?
X squared minus 6x plus 45.
Plus 45?
Yeah.
Of course equals 0. There's your equation. That is the same equation I got. Annie, how'd you do that?
I did like completing the square backwards. So I moved 3 back over to the x side and then squared both sides.
So she said x minus 3 equals plus or minus 6i.
And then I squared both sides.
So x squared minus 6x plus 9 equals
Negative 36.
negative 36.
And then I like moved the 9 over to like
Actually,
yeah.
you could just move the 36
Yeah.
over. Yeah. Good thinking. Good thinking. Anybody have a different strategy? No? Okay. All right, perfect. All right, solve algebraically. Little absolute value inequality. Solve that algebraically. And it doesn't matter how you solve it. You can solve it any way you want, as long as you're not graphing it on your calculator. number line and got 1 to 6. X is between 1 and 6. That seem right? Alright, let's write the equation of a circle when all we know are the endpoints of the diameter. That's what I got. Leo's nodding. Good. Everybody keeping up here? Anyone have a question? Yep.
Could you show how you get 13?
I found my midpoint, or here's my circle. I found this one to be 1,5 and a 4,7 out here. So I found the distance here. So 4 minus 1 squared is 7 minus 5 squared. So that'll be 9 plus 4 root 13. So the radius is root 13. And when I write my answer, then I square it. If you found the distance between these two, that would not be a radius. You'd have to divide it by 2. Okay? All right. One more. Got a piece of paper that is 18 by 50 inches. We're going to, I'm gonna write all this out, but we're gonna cut the corners out, pull up the flaps and the box, okay? So I want you to find the dimensions of the box with maximum volume. And then I want you to find size of the corners. So volume is less than 1,000. Alright, so it's a 2-part problem. Here's your paper, you're gonna cut out the corners, hold out the flaps.
Use our calculator.
You use your calculator, yes, I'm sorry, yes. This would be a calculator problem.
corners combined is greater than 9.
Okay, yeah, so it would be 9.
Alright, how are we coming? Think we got some answers here? You got something? What is that? Okay, so, moving back
For the first one, I got the max volume is 1,680.0.6. Yep.
So this was the maximum volume. Now, okay, so Will says the maximum volume is 1680.046. Is that what you got? Okay, but be careful. What was the question? Find the dimensions, right? So this is the maximum volume, and that could be a question. What is the maximum volume? There it is. But since we wanted the dimensions, we really wanted the x coordinate of that point. Anybody got that one? Leo? 4.0228. Yep, that's what I have too.
How did you get the max volume?
Well, you graph the equation,
Yeah.
and then second, count maximum, right? So just like we've done zeros, we've done intersections, max and min, it's all the same. It's all in the same location. All right, so I know x is that, so then I need my dimensions, which would be 18 minus 2x. Did you get that one? I think I did that one wrong. I got 50 minus 2x. I got this dimension right here to be 41.954. Does that sound right at all? And then what was this one? I know I did it wrong. Was it, I have 9.954. So there are your dimensions. 41.954 by 9.954 by 4.023. Is that all right? And then what did you have for this one, Will?
I had 0 on the 1.392. U 7.019.
Let's talk about that for a second. First of all, he wanted the volume to be less than 1,000, so he says it equals 1,000 at these two places. That's what I got. So when he looked at his picture, he had some kind of a hill, and here's 1,000. So he said this part and this part is where it's less than 1,000. I understand completely the 0 because obviously x has to be bigger than 0, so I get that. Where did that 9 come from right there? Yeah, it's half of 18. Because if you're going to make this box and your paper is only 18 across, then the biggest you can rip off each side would be 9. So that literally is the maximum x for this problem, would be 9, right? Okay. All right, is that good with everybody? All right, I'm gonna go ahead and hand out some papers, so we'll have them. Actually, let's do this. Let's have, you need 3 papers. You need 1 from each stack. I don't have extras, so please just take 1 from each stack. So we'll do this in orderly fashion. But just come up and get 1 from each stack. talking about the blue sheet. Okay, everybody got it? Okay, quick comment. The entire unit's homework is there. Okay, so there's 14 sections in unit 1, and all the homework is there. All the notes are not there. That packet would be like this thick. So only the first 3 sections are notes. I'll be giving you additional notes as we go on. But that homework packet you need to hang on to for a long, long time. Okay? Now, on the blue sheet, one side of it is unit 2 stuff, exponentials and logarithms. We're not going there yet. The graphical behavior, that side I want to start talking about right now because this is a big theme in the course. So, I'd like you to look at F, graph F. The note there is that the graph of F is increasing. Well, wait a minute, did you agree with that just by looking at the picture? I mean, that's not a profound statement. The curve is going up. And that means that its rate of change, AKA slope, is positive. That's something you've known forever. If the line is going up, its slope is positive. So the rate of change is positive. Okay. Now, that picture is considered concave up, as opposed to the one below it, which is concave down. So you need to get a feel for concave up, holds water, concave down doesn't. If a curve is concave up, that means that its rate of change is increasing. Okay, now, and this is where we can start getting things messed around in our head. Positive, a rate of change positive is different than a rate of change increasing. Alright? Increasing means it's getting bigger. So the slope is getting bigger. When the curve is concave up, your rate of change is increasing. Alright, let's look at the one underneath that, G. Would you say that curve has a positive slope? That means the rate of change is positive. The curve is increasing. The graph is increasing. It's going up. Rate of change is positive. However, this one's concave down. So it has a positive slope, but because it's concave down, its rate of change is decreasing. So it's like when you're pulling up to a stoplight in your car, are you still going forward? Yes, but you're going forward at a slower rate. That's what's happening here. Alright? Alright, now what about H? That one is decreasing. Draw it. What happens to your pencil? It goes down. So the rate of change is negative. It has a negative slope. However, it's concave up. So its rate of change is negative, but it is changing at an increasing rate. Oh my, this takes time to process and get straight in our heads. It's a lot. It's confusing. All right, and finally K. Obviously, it's decreasing, it's going down. That means its slope is negative, its rate of change is negative. What about the rate of the rate of change? Well, it's concave down. So so the thing is decreasing, the rate of change. The rate of change is decreasing. All right, I'm gonna let you process that for a minute, because that's a lot. And there are probably, I don't know, 10 multiple choice questions on the exam that are gonna have to do with that concept. Describe the rate of change. Is it positive or negative? Is it increasing or decreasing? So positive and negative is easy, going up or coming down. Rate of change is easy, concave up or concave down. Just can't get those two things confused. All right, I'm gonna stop there, and next time I see you, we'll have our quest. It will not take all period, so you will need to move along. Hopefully you have practiced. We will practice, because